Today's lesson, we are going to be adding on to the material that we already kind of talked about last unit that has to do with coming up with our scale factors, area ratios, and today we're going to be adding on volume ratio. So first, just a quick review of what we already know to be true. First of all, what a scale factor is. Our scale factor comes up when we compare two sides that are in the same spot, right? So we would say the definition is the ratio of the lengths of two corresponding sides of two similar polygons. Okay, our perimeter ratio, pretty much the same thing, right? You're just comparing the perimeters, which comes from the side lengths of two similar polygons. So the ratio of the perimeters of two similar polygons. And if you guys remember, our scale factor and our perimeter ratio are the same ratio, right? Okay, and then we have our area ratio, which is just a ratio comparing the areas. So just a quick reminder that since our perimeter and scale factor ratios are the same, so a scale factor or perimeter ratio can be written as what we say A over B, right? So what does that mean that we write our area ratio as? We only square the B? A squared over B squared. Okay, so we've got a little chart here below. Okay, on example number A, this 3 and this 2 are in the wrong spot. So this one should be the 3, this one should be the 2. Okay, so it says that we're going to decide if we think the solids are similar or not. If we say they are, we need to give a similarity ratio and an area ratio. All right, so let's compare sides here. We know that this side here, the 3, corresponds with what in the other shape? The 6. Okay, so we have the ratio 3 to 6. Can I simplify that? Yeah. To what? 1. Okay. What about this piece here that I'm saying has a length of 2? What does it correspond with? 4. So 2 over 4 will simplify to, good. All right, and then this side over here, the 3 corresponds with, good, and 3 over 6 will simplify to 1/2. All right, so what do we think? Are these two similar figures? Yeah, why do we think that? Right, they all have that same scale factor, same ratio. So yes, because they had the same ratio. All right, so since we said yes, they say we need to give them the similarity ratio. So what did we think our ratio was after simplifying those? 1 to 2, good. And then they also want us to write that as an area ratio. So what do I do to turn it into an area ratio? Square it. So what does it become? Very good. Plus. All right. Example B. So here I've got 3, right? What does it correspond with in this other one? Good. So 3 over 6, we said simplifies to a half, right? Okay. What does this 2 correspond with here on the bottom end? The 3. So that'd be 2 to 3. Is 2 over 3 going to be equivalent? Okay, so that one's not equivalent. All right, here I've got 2, and it corresponds with the height of 3 again. Okay, so again we have a 2 to 3. Those two are equal, right? So am I going to be able to say that this figure is similar? No, because not all the sides are corresponding, right? If they are not similar, can I give a scale factor or an area ratio? No. All right, last one. On example C, the radius here, the 6, corresponds with what? Okay, so 6 over 5. All right, the height, 12, corresponds with, good. And we can simplify 12 over 10 down to what? Good. So do we think these are similar? Yes, for the same reason as part A, right? So what is our scale factor or similarity ratio? 6 to 5. So what would that mean its area ratio is?
36 over 25.
Good. All right, so this is all just a review of what we've previously done, right? So flip it over onto the back. We're going to see how this compares to what we've been doing in this unit, Unit 9. All right, so for the next example, they want us to give all of these items for this given figure. When it says P and capital B, we know that's referring to the base, right? The shaded piece here is what they want us to be using as our base. All right, so what would be the perimeter of that base? All right, what would be the area of that base? Good. All right, now that we have that, they want us to give lateral area, surface area, and volume. All right, so lateral area. Since this is a prism, remember our formula is perimeter times height, right? Okay, so what did we say our perimeter was? Good, and what would that mean the height of this is? 10. So its lateral area is, very good. All right. Our surface area, remember, is lateral area plus our basis, right? So that perimeter times height plus our 2 bases. Well, we already found perimeter times height to be 280 plus 2 times our base area, which we said was, good. So what's our surface area? What is it? All right, and then lastly, they want the volume, which is represented by base area times the height. Our base area is that 48, and we said our height was 10. So what's the volume? Good. All right. Okay, so now they said that we are supposed to double all of those values that are the measurements of the sides and fill in this chart below. So I've got some prism where now instead of the height being 10, it's 20. This side instead of being 8 is now 16, and this side instead of being 6 is 12, right? So we're still going to consider this piece as our base. And now I need to give all the new measurements, now that I changed its dimensions by doubling them. All right, so what would be the perimeter of our new base? Good. And our old was 28, or the original was 28, okay? What would be the area of the base on the new one? Good. And our original, we said, was 48. Okay, for lateral area, we said lateral area was perimeter times height. So for us, that's 56 times, what's our new height? 20, right? So we get what for our lateral area? Good. Compared to our original 280. All right, surface area is this same lateral area plus 2 of the bases. What do we get for our new surface area? Good. Compared to our original 376. All right, and then new volume, that's that base area, 192 times the new height, 20, gives us a volume of compared to our original 480. All right, now it says since we've doubled the measurements and found all of these new dimensions, they want us to write a set of ratios for each one of these items. So we know the similarity ratio is 2 to 1 because we doubled each measurement, right? Okay, so our perimeters. So new perimeter, 56 over old, 28. What does that simplify to? 2 over 1. Which makes sense, right? Because we said our similarity ratio and perimeter ratio should always be the same. All right, area of the base. 192 over 48, which simplifies to, right? Makes sense, right? Because we said it should be the square of whatever we have here. Okay, for lateral area, we've got 1,120 over 280. What does that simplify to? 4 over 1 as well. Okay, and then for my surface areas, I've got 1,504 over 376. What's that simplify to? Also 4 over 1. Okay, so lateral area and surface area, they are types of areas, so it makes sense that they have the same ratio as our two-dimensional base area, right? All right, then lastly, our volume.
We are doing a secure hold. Students, you're in the hallways, please return back to class.
All right, so for our volume, we've got 3,840 over 480, and we just need to simplify. We get 8 over 1. All right, so then what do you guys think that means the rule is? It's cubed, right? So if our scale factor or similarity ratio is A over B, so that's for our side lengths, right? What do we know the perimeter ratio to be? Also A over B. All right, and then what would that mean our area ratio should be? Good. And our volume, you guys said our new rule will be X. All right, so then it asks, when would I use the ratio of lengths? Well, we would need to do it if we're looking for a missing side, right? Or if we're looking to find a missing perimeter. Or, remember, perimeter can also be called circumference, right? So when looking for a length, perimeter, or circumference. Okay. Next, they ask, when might we want to use an area ratio? Probably when we're looking for a missing area, right, of any type, whether that's base area or lateral area or surface area. So when looking for area, okay, and then they ask, how do you get a ratio of lengths from a ratio of areas? So how do you go from area back to ratio of lengths or scale factor? Take the square roots, okay. Okay, lastly, when might I want a volume ratio? Well, probably when we're looking for a missing volume, right? and then they asked, how do I get a lengths ratio from a volume? So how would I have a volume ratio and go back to my scale factor? Cube root. Good. And remember, we do have a function for that in our calculator, math, and then you pick off the list the cube root.